Alright, welcome back to Maths Concepts. If you have not yet subscribed, please do so, like and share these videos. What we're going to be looking on today though is CAPE Unit 1, Module 1, Question 1A and B, the June 2022 exam. Alright, so the first question that comes is a truth table question, and it reads, let P and Q be any two prepositions. Complete the truth table below. Alright, so what we are looking at here is we're looking at the possible outcomes for P and Q. Alright, and we're talking about true or false. It's all about what is true, what is false. The T represents true and the F for false. So the possible outcomes are as follows, and I'm just going to highlight them. The possible outcomes. So here are they. Alright, so we have a case where you have P is true, Q is true. It could be that P is true and Q is false. It also could be that P is false and Q is true. Or it could be a case where both are false, where we have false and false. So those are just some possible outcomes, right? So what we're going to be looking at is not Q. Not Q is simply the opposite to what Q is. So if Q is true, not Q is false, and where Q is false, not Q is true. So I'm observing this column right now and this column right now. All right, so let us look in it. So we're going to fill out the not Q, right? So the first one I have here, as you can see, Q right there is true, which means that not Q for that row is false. Very straightforward. And right here, Q is false, not Q is true. The next one, Q is true, not Q is false. And when Q is false and not Q is true. So right there, what we just came up with were the responses for not Q, which is the opposite of Q. Alright, so you could double check TF, FT, TF, FT. Alright, the next question that we want to look at though is not Q and P. So this is not Q, and this symbol stands for and whenever you're using and, we're searching for truth. So we would have to get two T's for it to be a truth, right? So let's look at not Q and P. So basically I'm going to highlight, we're looking at the P and we're looking at the not Q, right? Not Q. So let's view them one at a time. Now look at this. We're looking at when P is true and not Q is false. So if we have a true and a false, then we will get a false, because for us to get true, it is an and statement, so we need both of the statements to be true. Let's go for the next one. We're looking at a true and a true there, which means the final outcome will give us a true. Remember, we're doing and. So let's go for a false and a false. Definitely this is also a false. And lastly, we're going for a false and a true. We're still going to be having a false because it's an and statement, which means that we must have the two T's for us to get a final T. Alright, so let's take those off and we go forward for the next question. We're looking at completing where we have P or, so that V looking thing is or. So let me put it there, we're doing an or. Alright, so we're looking at P or, in the bracket we have not Q and P. But definitely remember we have these columns. The P column is here and the not Q, the not QP is here. So we definitely have these columns. So what we're just going to do is just to go through and make sure that we are picking up the right letters. Remember, we're dealing with R. And what's the idea behind R? If you're dealing with R, then you only need one. You only need one true, and then you're good to go. So let us check this out. We're talking about P, or not Q, and P. And we have those. So let's stretch. So we're talking about T to a false, right there. So it's a T to a F. Finally will give me a T, because we only need one T and we're good. At least one. T to T, we're still gonna get a T. Alright? T to T, we're still going to get a T right there. Then we have a F to F. False to false, that's gonna be a false, right? Because we're looking for truth. And then the next one says false again to false. Definitely that will be false. Alright, so our final responses are as follows: T, T, F, F. And there we have it. We would have completed the truth table as they had asked us to do right there. Alright? Alright, now let's focus on the other question. Let me take off these quickly. Alright, let's look on the other question. The next question says here, it says, hence state whether the statement not, let me highlight this, the statement not Q and P or not Q and P are logically equivalent. Justify your response. For these two statements to be logically equivalent, they would have to be exactly the same. And so currently I could say no, right? They are not, right? So they are not logically equivalent. They're not logically equivalent. I'm going to justify that. The justification will simply be, let's look at this. Under the not Q and P, we had a false, then a true, then a false, and a false, right? But under the other statement, we had true, then false, then false. You could see that it's not the same thing because these two differ. So the moment one pair of things differ, then it's not logically equivalent. All right, so that's for that. So it's not logically equivalent because the two statements are not identical, they're responses. All right, let's go forward. Next question now. All right, so here's the next question right here. So the next question reads as follows. It says determine the values of a, b, and c such that 2x squared minus 7x plus 12 is equal to a open bracket x minus 2 open bracket x minus 1 minus b into x minus 3 plus c. Alright, with a question like this where we're asked to find the values for a, b, and c, what we want to do is to unfold everything and then equate coefficients, right? So what do I mean? All I have to do here is that I want to use the right side here, and I'm going to just expand the right side. This right hand side, I'm going to expand it, and then I'm going to compare it with what I have on the left hand side. So I will be starting off with the right hand side. So let's go. So let me write down what we have here. So definitely I'm looking at a open bracket x minus 2, and then we have x minus 1, we have minus b, x minus 3 plus c. So what we want to do is to expand. So in expanding this, there are a number of ways we could do it. I could keep the a here and expand what is inside here. Multiplication is going on. I'm going to deal with this quickly. So x times x, that is x squared, and then we have a minus 2x and then I have a minus x, and then I have a positive 2. That's what I have right there. If I distribute my negative b inside, I have negative bx, then I have positive 3b, and then this is going to be a plus c. In simplification, I'm going to distribute my a inside. At the same time when I'm doing that, I want us to pay attention to this. So what I have here is going to be a negative 3, all right? Negative 3x. So what I go through, understand what I'm going to do now. All right, so distributing the a inside, I'm looking at ax squared, and then this is actually negative 3ax, all right? And then I'm going to have a positive 2a, all right, coming out of that. Then behind that, I'll have my bx plus 3b plus c. What I want to do now is to collect my like terms, right? So when I say like terms, I want to put together the x squares, I want to put together the x, and I want to put together the constants, all right? So the squares of x here, ax squared, does not have anything like it, so it's going to stand there. However, I'm going to introduce a plus sign, and I'm going to open a bracket just to sort out this term that I have here with the x. So if you look, I'm going to have to highlight this. This is linked to that because they do have the x on it, and they're going to represent this x up here in the quadratic expression. So negative 3 with an a and the minus b. I put them together, but I'm factorizing out the x off them immediately. All right? So I'm factorizing off the x off the negative 3ax and the minus bx. Put them together because they are attached to the x's. After that, I'll have a plus 2a and a plus 3b and a plus c. So that's my constant term that I have after that. Let's continue. All right. Now, at this moment, we're able to do a few things. If we are supposed to be matching what we have, right? What is on the left side to what is on the right side, we definitely could see some familiar stuff coming out here. But I'm gonna put them beside, all right? So let me change the marker for that. All right, I'm just gonna put them underneath. If you should check this out, I'm going to isolate this, I'm going to isolate this, and I'm going to isolate these. Now, if we're focusing on everything, I want us to look back on the left-hand side up here, focusing on that original quadratic that we got. What we have here is the 2x squared. The 2x squared will link to the ax squared, and the negative 7x is this middle piece here, the minus 3a minus b and into x there. And then the 2a plus the 3b plus the c is lightning onto this positive 12 that we're looking at, right? So definitely we're going to use this tool now in an effort to solve for a, b, and c. All right, let's go. At this moment, we can say, all right, to find a, we're going to equate this. Ax squared is the same thing as 2ax. If we should drop the x squared, as you could see, a is equal to 2, right? So a is 2, and we have that right now. Now, the intention is to find b right now. So let's go for b. B though, so we could say that b is the coefficient of the x. So we're not going to be plugging in this in the mix. We're just going to equate this. So we're going to say negative 3a minus b is equal to the negative 7. All right? So we're equating the coefficients now. Remember that we have a value for a. So let us go further. Negative 3 times 2 minus b is equal to negative 7. Lastly, negative 6 minus b is equal to negative 7. Let us add 6 to both sides in solving. Then minus b is equal to minus 1, right? Minus b, let me write my 1 better. minus b is equal to minus 1, and then that means b is equal to positive 1. We can multiply negative 1 by both sides. So here a is 2 and b is 1. So the last thing that we're about to do, the last thing that we want to do now, is to find the value of c, and we're done. So in an effort to find the value of c, remember that 2a plus 3b plus c is equal to 12, because that's the constant. Remember that we have a value for a and b, so we could substitute 2a plus 2a times, well, 2a is going to be 2 times 2 plus 3b, and b is 1, plus c, and this is equal to 12. So 4 plus 3 plus c is equal to 12. 7 plus c is equal to 12. So let me write this a little better. 7 plus c is equal to 12. So this is 7 right here. Then we could say that c is equal to 5, right? So here it is that we have found the values for a, b, and c. And there it is. Look out for the next question coming, right? See you next time.